Welcome to the walkthrough of Assignment 1 in my CS253 course in the fall of 2023. The purpose of this assignment is to deepen your experience using the Java Fork Join framework, which the Java Parallel Streams and Computable Futures frameworks use as their default data parallelism engine, as discussed later in this course. In particular, you'll use the Java Fork Join framework to obtain, transform, and store images in parallel. The code you'll write here will have a GUI and will run as an Android app. Please use this GUI along with the unit test discussed below to help debug and evaluate your solution. The following resources may be helpful in completing this assignment. Good overviews of the Java Fork Join framework appear here and here, and a technical discussion of the Java Fork Join framework appears here. Naturally, we'll cover this material in class. The Image Crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1, however, you only need to be aware of the following folders: Image Crawler crawlers, which contain the skeletons you need to fill in, as described below, and Image Crawler source test, which is a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 31, so you need to select an emulator that uses API greater than or equal to 31. I recommend API 33. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here tasks to provide a working solution. Don't change the overall structure of the skeleton, just fill in the to-do tasks, and please do not delete the to-do markers. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the Image Crawler folder. First, you need to complete the to-do tasks in various methods of the forkjoin_crawler.java file to obtain, transform, and store images. This class uses the Java Fork Join framework to perform an image crawl starting from a root URI. Depending on the parameters used to run the tests, images from an HTML page reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored locally in files on the Android computing device. You'll also need to complete the to-do marker in the common/student.kt file to set the type field to be either graduate or undergraduate, depending on how you're enrolled in this course. The bulk of code for the app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore convert this Java 7-based class to the Fork Join Crawler class that uses the Java Fork Join framework. Your solution can use loops and if-else statements in this assignment, since the Java Fork Join framework doesn't integrate cleanly with Java's functional programming features. We may remedy this issue later in the course. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available at this link in my GitHub repository. Now that you've set up your GitLab account, you can pull the skeleton code in your repository, read it carefully, and complete the to-do markers. Unit tests in the Image Crawler source test folder are provided to increase our confidence that your implementation is working as expected. It's essential that you use the Android Studio GUI to run these tests locally on your computer, as described here and shown later in this video. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please address these issues prior to your submissions to streamline our programming assignment and review process. Assignment 1 is designed to give you experience programming directly to the Java Fork Join framework APIs. There are more moving parts in this assignment compared with later assignments that focus on Java Parallel Streams, which hides these fork join details from app developers. Therefore, please start the assignment soon and ask questions in class, office hours, and on the discussion forums. The app, image crawler skeletons, and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we've walked through the specification of Assignment 1, let's take a look at the skeletons you need to fill in. These all reside in the Fork Join Crawler file. This file contains the Fork Join Crawler class, which is an implementation of the Image Crawler superclass that uses the Java Common Fork Join framework to perform an image crawl starting from a given root URI. Images from an HTML page that are reachable from this root URI are downloaded in parallel from a remote web server or the local file system. In either case, they're transformed and then stored in files in the Android device, where they can ultimately be displayed to the user. Your implementation should not use Java Streams features. We will cover them later in the course, but you should reuse existing code by making calls to the appropriate methods in the Image Crawler superclass, such as get or download image, apply transform, create new cache item, and download image, as well as various methods in the web page crawler helper class, such as getPage and getPageElements. If you don't make those calls appropriately, the unit tests will complain. Also, please make sure to review and comment your code thoroughly, or I will not review it. So make sure after you write it, you review it, and then you comment it carefully to make sure you capture what you're doing, and then make sure that's what I see when you submit it. If you send me code that is not commented, it will not be reviewed. So let's go ahead and take a look at fork join crawler. Let's take a look first at the perform crawl method. This method will perform a web crawl using the Java common fork join pool and the parameters that are passed in, which is the URL that we're starting the crawl at this point and the current depth in the recursive processing. And you can see it returns the number of images that were downloaded, transformed, and stored at this URL. So you need to replace this code with the appropriate implementation that uses the Java common fork join pool. And to do this, you need to watch the videos we'll cover in the course about the common fork join pool and Java fork join pools in general. Next, let's take a look at several factory methods you need to fill in. The first one will create the perform transform task object. And so the name of the factory method is make perform transform task. And you have to write the code here that does the appropriate call. This is a pretty simple method to implement. Likewise, you also have to implement a factory method that makes a new process image task called make process image task. Once again, you fill it in to replace return null with a solution that makes the new process image task with the right parameters. And then finally, you'll make a URL crawler task. And once again, you have to write the code that will make the new URL crawler task based on the parameters that are passed into it. A lot of this stuff should be pretty straightforward, but there's some subtleties. So make sure you think about this carefully and take a look at the unit tests and see what they're doing. Let's now take a look at our first nested helper class called URL crawler task. And you can see this extends recursive task. And that means it's going to end up implementing a compute method that returns an integer, which will be the number of images downloaded, transformed, and stored, starting at the URL that's passed to the constructor. Now here, you're going to have to write a few fields here and then initialize those fields in the constructor. This shouldn't be a particularly hard thing to do, but you need to do it. Otherwise, that information will not be available to the compute method. Now, the compute method that you write will involve replacing return 0 with a solution that will check to see if the current depth is within the max depth, that being what's passed to the constructor, and if the URI that was passed to the constructor hasn't been visited before. And if it's the case that you're within the max depth and you have not seen this URI before, then you're going to call a helper method to crawl the page. And without giving away too much, that helper method down here is the crawl page method, which takes the page URI and the depth. And it assumes that the sanity checking was done by the compute method. And what this will do is it will get the HTML page associated with the page URI, and then it'll process that page. Now, to do that, you're going to need to call some helper methods that are defined in the web page element class. So you need to understand how that works. And then you'll also need to use a helper method to expand the Java common fork join pool as needed. And another hint, if you look way at the bottom of the file, you'll see the method that's involved there that you also have to implement. Then there's also a method that you're going to call, which is the one that processes the page. And this assumes that you've got the appropriate page and the depth. And now you're going to use some other helper methods to get all the image and page elements from that page. And once again, you'll use a method that's defined on the web page element class. And then you'll take those particular elements, figure out if it's an image or a page based on some type information. And then you're going to go ahead and crawl and count them accordingly, and then return a sum of the number of images processed. And in order to do that, you're going to use this helper method here called sum results, which is going to take a list of fork join tasks, which of course will be created up here in process page. And then you're going to join all the fork join tasks and return a sum of the images that were given back by each of the tasks. So this again requires you to watch the videos and understand how the fork join framework works. And as before, please make sure you take a careful look at the way in which the unit tests are making sure you're making the right calls at the right place. So let's take a look at process image task. And the purpose of this particular nested class is to download and process a given image. And it also extends recursive tasks, so we can fork and join it using the Java common fork join pool. So once again, you're going to need to add one or more fields here, and you need to initialize them in your constructor. And then down here in the compute method, you're going to replace return null with a solution that uses a helper method that's defined up in Image Crawler that will either get or download an image from a given URL, depending, of course, whether it's been cached or not. And then it'll also use some helper methods that are defined in the Image Crawler superclass in this class that uses manage blocker. So you're also going to have to sort of think about how you're going to do this. And one of the things you're going to use here is one of the helper methods will be called transform image. And what you do is you have an image here. And what you're going to do is first replace this call with something that will apply the current set of crawler transforms on the image parameter, the thing that's passed in here to the transform image method, and it'll return a count of all the successfully transformed images. And then you will take that result, which will come back here in this list of fork join tasks, and then you're going to call another helper method that will join everything together and return the number of non-null images obtained from each task. Once again, that helper method is helpfully defined down here, and it's called count transformations, and it will essentially iterate through all the list of fork join tasks and count the number of non-null images returned from each task when you join with them. Once again, you have to understand how to do joining, which is part of forking and joining. And of course, you also have to know how to do forking as well. So you need to fork and you need to join. And I'm being deliberately a little bit abstract about this because I don't want to totally give the solution away. Down here, we have perform transform task, which is going to perform a transform operation or transform operations on the appropriate image. So what we're going to do here is we're going to have some necessary fields, and we're going to pass in an image and a transform. You're going to stash those away here in the fields. And then the compute method here, because of course we're once again extending recursive tasks, so we have a compute method. This is going to be transforming things and returning an image. Before we returned an integer, now we're returning an image. And so what you're going to do here is you're going to replace return null with your solution that transforms and stores an image using helper methods that are defined in the image crawler superclass. So there's some helper methods there that you're going to need to look at. And if you read up the very top, you'll see a list of some methods. These are the methods you're going to need so you don't have to end up writing a lot of extra code. So this is about learning to reuse things that exist in libraries, such as image crawler, which is something I provided to you. The last two methods here are convenience methods. The first one is called call and manage blocker. Once again, we cover this extensively in some of the class videos. Here you're going to need to replace return null with your solution that uses the blocking task helper. And this is actually a helper class that's defined over here in utils to encapsulate the supplier parameter so that the operation that the supplier encapsulates will run in the context of the Java common fork join pool's fork join pool manage blocker mechanism. So call and manage blocker is going to basically forward to the blocking task to do that processing. Once again, we cover this in class in the videos. And then finally, there's a method called manage blocker download image. And what you'll do here is you're going to replace return null with the solution that converts the parameter, the item, to an image by downloading it as a managed blocker to ensure that the common fork join thread pool is expanded appropriately to handle blocking image download. And once again, this leverages the mechanisms that are provided in the common fork join pool for being able to grow the size of the pool. So those are the methods that you need to implement in fork join crawler. Now that we've walked through the specification and the skeletons, let's show how to run the unit tests. We don't have unit tests in assignment 1 yet. They'll be released in a few days as soon as we finish them off. However, once they're there, here's how you will run them. You'll come down here to image crawler source test, and you can right click with whatever means is provided by your IDE. The way of doing this is slightly different on Windows versus Mac versus Linux, but essentially you come down here and you click on the run test button. That will go ahead and compile and run the tests. Now, as I said, we don't have specific tests for the fork join crawler assignment yet. These are just running all the tests for my assignment. And as it turns out, of course, all of my tests pass. Your test should pass. You know your tests pass if you get green check marks for everything. You can also see up here it says tests pass, in this case 82. There's other ways to run the tests as well, but this is probably the easiest way to do it. So when we get the tests installed, I will go ahead and update the version that's on the web, and you'll have to do a git pull and then merge those tests in with your repository, which is good practice for learning how to use Git more effectively. Now that we've walked through the specification, the skeletons, and the unit tests, let me show you how to run the app so you can see it all come together. The way you do this is you come up to the top of IntelliJ and you select the app item from the menu, and then you click on the button here that's sort of the blue button that looks like an arrow. You can also run it from down here where it says run, and that will go ahead and begin the process of building the app. You can see here that it builds, and as long as it compiles correctly, it'll find the emulator that you've created. Make sure you create the emulator, and then the emulator is created, and at that point, the app will be up and running. Let's show how to run the app. First thing you do is click on the lady button icon, and you can select the version you want to use. Let's start by using sequential loops. Note, by the way, that your implementation is not going to have all these choices because we're just doing the fork join version in this example. But let's start with sequential loops, which is something that you'll have. So you select that and you click back over here on the left-hand side of the screen, and then you click this little button, and that will go ahead and download the various images and transform them. You can see this all works sequentially. You can see it worked by going from left to right, top to bottom. Now let's come up here, and this time we're going to select using the fork join version of this. Come back over here. You can clear this out by saying select all and then saying delete. So now all the images start with a clean slate. And now we click the download button again to begin the crawl. And you can see now it's doing everything in parallel using the fork join model. This is quite a bit faster. You can also see how long it takes, the number of threads and the images that are involved. So we have the fork join version with 96 images, 29 threads, and it takes about 3 seconds. Just for kicks, let's go back over here and go back to sequential loops. Let's just push on one icon, say select all, then say delete. And let's try this again and see how much longer it takes to run doing the sequential version. So here you can see we're doing it sequentially. And once again, we have 96 images. It takes almost twice as long. Naturally, this is an emulator, so your mileage may vary. We're also not doing this over the network, so we're not having to pay the costs of doing network downloads. So now let's go over here and we'll play around with some of the options to make it run slightly differently. So we can make the crawl speed run at a different rate. Let's make it run not quite so fast. We also will have enabled the speed bar, which will show you what's happening. And then we'll also show you the progress. You can toggle these things. You can see by selecting the menu items. So let's go back over here this time, and we will do the sequential loops. I may not run it the entire time because it'll take a little bit of time to do it. But you can see now it's visualizing what's happening. The spinning disk means that it's in the process of downloading and writing. Now it's going ahead and it's applying the filter. And when the filter is done, you'll see it make changes. This is also the sequential version, so it's just doing things from left to right, top to bottom. This is taking a while to run, so I'm not going to let it run very long. The way you cancel it is you just click on this icon down here and it cancels the work. Now let's come up here and we will select the fork join version using a slightly different way of doing this stuff. And you can see how much faster it runs. It's basically doing all these operations in parallel. And so you can see that it's downloading things in parallel. It's filtering things in parallel. And you can see that writing takes place in parallel. So lots more visualization of what's happening. Now, again, this is not actually the time it's taking to do the work. It's just visualizing it in a slower rate, so it's easier to see what's actually taking place. So that's the way the program works. If all goes well, then you should see lots of nice images downloaded and transformed. And this is a good way to get a bird's eye view of whether your program is actually working correctly. So you could actually use this while we're getting the unit tests finished. You could actually try running the app as you put your solution in and see what it does. The unit tests are nice because they will actually give you more specific feedback on what you're doing wrong, but we need to finish them up yet, and I wanted to make sure the assignment was ready to go. So that's assignment number 1.